In this experiment, two pieces of charged tape are prepared and their interactions with each other is observed. We are able to create a computational model in GlowScript to estimate the amount of charge on each tape necessary to float one above the other. The charge is evenly distributed across the length of the tape. A summary of the findings is shown, where we see that the charge of the tape is positive and has a charge of 3.04 times 10 to the negative 9. Some of the fundamental principles used in this lab include Newton's second law. Newton's second states that the net force of an object is equal to the change in momentum over the change in time. From this law, we are also able to derive the updated velocity formula. The second key concept uses the electric force through Coulomb's law. This is used to express the force through which charged particles attract or repel one another, such as like charges repel and unlike charges attract. Below, we can also see the equation used, which states that the electric force is equal to the Coulomb's constant times the product of the charges of the particles divided by the squared distance between the particles in the direction of our hat. Additionally, we'll be using the concept of superposition, which involves dividing a charged object into segments and summing the electric force of each in order to find the net force. We use this concept to find the charge distributed across a piece of tape. For this lab, some key assumptions were established. Firstly, a charge is evenly distributed across the tape. Therefore, each piece of tape was modeled as several segments, each with equal charge, in order to apply the principle of superposition. Secondly, air resistance is ignored for this experiment. And lastly, both tapes are equal in charge. Here I have laid out the procedures for this experiment and the type of testing done to analyze interactions. These are the same experimental procedures from Lab 1. Here we have the main observations from the interactions with the U-tape, which were analyzed in Lab 1. From these observations, we can conclude that the U-tape is positively charged since it attracts to an object that is negatively charged, but repels when the object is positively charged. According to Coulomb's law, like charges repel and opposite charges attract, thus we can conclude that the U-tape is positively charged. Here's a free body diagram of the interaction between the held U-tape and the suspended U-tape. The system includes a suspended U-tape and the surroundings is a held U-tape and earth. For the suspended tape to float, it must be in equilibrium, thus the net force is 0. Thus, the force of gravity will be equal to the electric force. Here we have some experimental data and calculations with the charged tapes. From these calculations, it is important to note the vertical distance between the two tapes is 0.025 meters. The tape mass is 0.00017 kilograms, and the force of gravity is the mass of the tape multiplied by gravity. Thus, the force of gravity in the U-tape is 0.0016 in the negative y direction. All relevant equations are noted, and the tape length and width was determined through measuring. Next, we calculate the charged tape of the tape. Since the tape is a uniformly distributed charge, we will use the equation for an electric force of a uniformly charged rod to estimate the charge of the tape. We will set the magnitude of the electric force equal to the magnitude of the force of gravity. By doing so, we are able to manipulate the equation and solve for Q, the charge of the tape. Below you can see the equation used. By plugging in our known values, we are able to solve for Q and get an estimated value of 3.04 times 10 to the negative 9. The computational model was done in GlowScript. Here I have my code showing the relevant calculations. For the section of the constants, the values were taken from the previously shown calculations. The Opez constant is a Coulomb's constant. All the equations were taken the same method as previously denoted, but written in the GlowScript language. Also note that the true charge of the tape is 3.04 times 10 to the negative 9. In the bottom left, we can see the electric field function used to compute the electric field of a point charge. The tape was separated into 30 point charges which approximates the integral method used to calculate the electric field of a uniformly distributed charge. To the right, we have the code which creates a line of charge. Now we continue with the calculations done to find the electric force from each point charge, as well as the electric force on the top tape by the bottom tape. Additionally, the electric field of the top tape due to the bottom tape is also calculated. And lastly, we calculate the electric force vector and gravitational vector, and the code returns their magnitudes. This slide shows the visualization of the code with the results of the magnitude of the electric force and magnitude of the gravitational force. Here is an overview of the results. There is an equilibrium for the suspended U-tape to float. Thus, the net force is 0. The force of gravity is equal to, in magnitude, to the electric force. Therefore, we were able to calculate the charge of the tapes to be 3.04 times 10 to the negative 9. The magnitude of the electric force and gravitational force were calculated to about 2.169 times 10 to the negative 3. It is also important to note that there is possible sources of error, such as inaccurate measurements of the tape length, width, and separation distance, as well as possible error due to rounding. Additionally, the charge of the tapes may not have been totally equal between both tapes or equally distributed across the tape, which could result in findings that are not exact. When comparing the point charge model to the value we got in the line charge model, they differed by a factor of about 2, with the line charge model having a larger charge value. These estimates may differ due to the different considerations, such as considering the tape as a single point charge versus a uniformly distributed charge. By evaluating the tape as a uniformly distributed charge, we were able to get a more accurate value of the tape's charge.